Chapter 7, Section 3, Multiplying and Dividing Rational Expressions. We start with multiplying and dividing rational expressions because it is a little easier to multiply and divide fractional things than it is to add or subtract them. When you add or subtract them, the denominators have to be the same, but when you multiply and divide, they don't. So we're going to start with multiply and divide. A rational expression is a fraction whose numerator and denominator are non-zero polynomials, and the domain of a rational expression excludes values that make the denominator zero. So here we have to watch out. Remember, you can't... let me get my pen. Remember, you can't divide by zero. This is a no-no. So if you have x plus 2 in the bottom, whatever makes that zero is a no-no. So we couldn't be x is not equal to negative 2 because 2 and negative 2 would make a 0 in the bottom. It can be any other number. It just can't be those. Okay? So a rational expression is in simplified form when its numerator and denominator have no common factors other than 1, positive or negative 1. So let's refresh a little bit about simplifying fractions. Okay? If you have a fraction that has a common factor, so on this one we've got AC over BC. The C's can divide out. They reduce to a 1 because C divided by itself, C divided by C is 1, leaves us with just AB. So if we had 15 over 65, 15 is actually 3 times 5 and 65 is 13 times 5. They both have a factor of 5 that we can reduce out, leaves it 3/13. The same can be said of things that have expressions in them because each expression is like its own piece. I know it's got a lot of parts to it, but it's its own piece. So 4 times x plus 3 is like a times c. And then that's over c times c. So if we had a times c over c squared, or if we had a times c over c times c, those c's cancel out and we just have AC. That's what's happening here. These factors just cancel out. That's how we simplify. So it's usually about 2 steps. First, factor the numerator and the denominator, and then you have to divide out the things they have in common. So we're going back to that quadratics thing again. We're going to be factoring quadratics. We got to be able to break them apart into their pieces. If we can do that, then we can simplify a rational expression. So here's an example. X squared minus 4x minus 12 divided by x squared minus 4. I'm draw my big line here. X squared minus 4x minus 12. Each one gets an x. Factors of 12 that subtract to 4. Well, 6 times 2 is 12, and 6 minus 2 is 4. So 6 and 2, and I need it to be negative, so the bigger number has to be negative. This one's going to be positive. The bottom one is a binomial piece, and it has a difference, and x is squared, and 4 could be 2 squared, so I have a difference of squares. Each one gets an x, each one gets a 2, one's plus, one's minus. Now, the reducing part is which ones match. Well, I got an x plus 2 and an x plus 2. So x minus 6 over x minus 2. X cannot be 2. How do I know? Take the denominator, x minus 2, set it equal to 0. Whatever makes that 0 true, that's what x can't be. Okay? But you do have to watch out for that. That's one of these things. If you got x in a denominator or x in a radical, you're gonna have a limit to what x can be. All right, here's a couple right here. Give it a pause, try them, come back. Let's see how it goes. All right, let's look at number 1. Number 1 is already factored. That's nice. So all I got to do is scratch out the things that they have in common, top and bottom. And that leaves me with 2 over x plus 3. X can't be 3. Don't forget what x can't be now that x's are in the bottoms of denominators. All right, the top one, x plus 4, that can't be factored, but x squared minus 16. 16 is actually 4 squared. I've got a difference of squares. So I've got x plus 4 over, and they both get a 4. One's plus, one's minus. Those scratch out. So what's left in the top? Well, remember, you could always say everything is times 1. So we've got 1 over x minus 4, and x can't be 4. Mr. Maggart, how'd you get the 4? Well, x minus 4 equals 0. Add 4 to both sides. X. What makes that true is 4, so x can't be 4. Number 3, 4 over x times x plus 2. Okay, 4 over x times x plus 2. Let's see. 4 can't simplify any further, and the bottom is factored, and they don't have anything in common, so that is the simplified form. Now, x can't be two different things. I've got two different sets of x. I've got x, and then I've got x plus 2. So x can't be, x by itself is just 0, and x plus 2, opposite to get out, negative 2. It can't be those two things. Number 4 is our hardest. We have to factor both of them. I'm draw my divide line, put my parentheses. Top one, each one gets an x. Factors of 3, well, 3 and 1. That subtract a negative 2, so I need a negative 3 and a positive 1. Each one gets an x. Factors of 6 that subtract to 1. Well, 1 times 6, if you subtract, is 5, and 2 times 3 subtracts to 1. So 2 and a 3, and I need it to be negative, so the 3's got to be the negative. So x minus 3 is the thing they have in common. X plus 1 over x plus 2, and x can't be negative 2. That's simplifying rational expressions. Now let's look at multiplying. The rule for multiplying rational expressions is the same as the rule for multiplying numerical fractions. Multiply the numerators, multiply the denominators. Do not cross. This is not cross multiply. This is straight multiply. You can cross reduce, but you don't cross multiply unless there's an equal sign to cross. So we just go straight. Numerator times numerator, denominator times denominator. Write the new fraction in simplified form. Similar to rational Similar to rational numbers, rational expressions are closed under multiplication. We haven't talked about any of that stuff, so we don't really care. Okay? But if you have A over B times C over D, it just becomes AC over BD, and then you simplify if possible. I simplify early and then multiply. They're showing simplify after, which is fine. They've even showed you what it means. So 5x squared times 6xy to the third. The 5 times the 6 is 30. X squared and x, same base, add 2 plus 1 makes 3. Y to the third stays y to the third. On the bottom, 2 times 10 is 20. X times 1 is just x. Y squared and y makes y to the third. Okay? Then they broke it back out into the factored pieces. 30 and 20 both have a 10 factor, and you got a 3 and a 2. X can break off of x squared, and there's an x in the bottom. That leaves you with x squared, y to the third, and y to the third. And so they're showing you all of the things that they have in common. And what's left is 3x squared on top and 2 on the bottom. Now, I would have done it early. I would have said 5 goes once and twice. 2 goes once and 3 times. There's an x down here, and I'm going to turn that into a 1. There's 2 y's here. That goes to a 1. There's a y here. That goes out. And so I've got x and 3, 3x squared. And all I got down here is 2. I simplify early and then multiply the smaller numbers. They multiply first and then simplify the bigger numbers. Whatever way makes you happy is fine. But you've got to deal with fractions. You can't just turn these into decimals. So fraction practice is a good idea. Find the product. Okay, I simplify early. So immediately I already see that 4 goes into 8 2 times, and 2 goes into 2 times, and all of those numbers are gone. Y here makes that y squared. Y squared and y squared goes out. X drops that down to x squared. So now my bottom is all gone. And all I have is the top. 1 times 7 is 7. X squared times x to the 4th is x to the 6th. And y times nothing is y. Just like that. And it all goes away. Now, we still have limits. Because remember, back here, we had an x and we had a y. So x back in the original problem, x can't be, if it doesn't have a plus or minus or anything next to it, then it's just the x part, and x can't be 0. Same thing with y. If y is not adding or subtracting 2, it's just y. Can't be 0. We got to add that on there. Don't forget to put your limits. You'll see that as you start looking at answers. Okay? All right, bigger. I like to reduce first. That means I'm going to factor first. So I'm going to pull out what they have in common. Here, 3x leaves me x minus, no, it leaves me 1 minus x. Down on the bottom, each one gets an x. Factors of 5 that subtract to 4 would be 5 minus 1. On the top, each one gets an x. Factors of 20 that subtract to 1 would be 5 minus 4. And then we have a 3x. Okay, well, the 3x and the 3x goes. We got x plus 5 and x plus 5. Now, if you look, we're really close here with 1 minus x and x minus 1. We're really close. But they're not exactly the same yet. The x is negative in the top, it's positive in the bottom. The 1 is positive in the top, it's negative in the bottom. So what I have to do is pull out a negative 1. If I bring a negative 1 out here, that changes this sign and it changes that sign. Now they match up and I can get rid of them. But what I have left is negative 1 times x minus 4. And if I distribute that back in, that's negative x plus 4. And then x cannot be, and we got a couple of things to consider here. We had a 3x, we had an x plus 5, and we had an x minus 1. That's 3 things that x can't be. X can't be 0. It's 3x equals 0 divided by 3. X equals 0. We got add 1. So x equals 1. X can't be 1. And we got subtract 5. X can't be negative 5. So it can't be 3 things. Okay? Those are our different pieces. Okay, well, this is just an over 1, so we don't have to worry about that too much, but let's break it up. X, 9. Let's see, factors of 9 that add to 3. Ooh, there aren't any. That's not good. What are we going to do there? Okay, well, put them together. What are they doing? Oh, I got it. So since we can't factor it, we can at least put them together. X plus 2 times x squared plus 3x plus 9 over x to the third minus 27. Okay? Now, x to the third minus 27, that is a difference of cubes. I've got a difference, and 27 is 3 cubed, and x is cubed. That has a pattern to it. So we got x plus 2 over x squared plus 3x plus 9, and we've got a pattern. It's going to be same, change, always positive. Each one gets an x, and it gets a 3. You get x squared, you get multiplied together, you get 3 squared. Okay, remember that pattern. You get a minus b, you get, oh, sorry, wrong letter. You get a squared, and then you get minus, or plus ab, and then plus b squared. So this is my a, that's my b. X is a, and 3 is b. So we plug them in. Now, let's get rid of things they have in common. Oop, there's one. Oop, there's one. We're left with x plus 2 over x minus 3. Now, we have to be careful. What do we pick for the simplified form? what can x not be? What would make it a 0 in the bottom? Well, let's see. We got to do the x to the third minus 27 one. So x to the third minus 27 equals 0. Add 27. X to the third equals 27. Cube root x equals 3. So x can't be 3. Okay? So there's our sweet little answer. Okay. Here's some to try. Give them a try, pause it, come back when you're finished. All right, here we go. I know 3 goes into 3 once and it goes into 9 3 times. I know 2 goes into 6 3 times and it goes into 8 4 times. I know x goes into x. I know 2y goes into y squared. X to the third would make that x squared. And that's all my pieces. So I've got x squared, y squared, and a 3. And I got 4 times 3 on the bottom. Ooh, look at that. 3 and 3 goes. So we can turn that into a 1 and make that a 4. And x can't be and y can't be. Now let's go back and look originally. 0 or 0. Okay, there we go. I'm going to erase that 1. I don't like it being there. There we go. Just like that. Okay, let's look at number 6. I'll even switch colors. All right, so we can pull out a 2x, which leaves us x minus 5. This one is a difference of squares, x plus 5, x minus 5. And okay. Perfect. All right, x minus 5 goes. The 2 goes. One of the x's. Okay. So we got x plus 3 over x times x plus 5. And then x can't be equal to, on the bottom, interestingly enough, they're saying just a 5. Well, actually, it should be 0, 5, negative 5. They only tell us that it cannot equal 5. They're going based on the answer. But even the answer says that it can't be 0. So we don't want to have that. Now, we have x in the top and in the bottom, so it kind of can still be 0 because, well, no, because if you did 0, you'd have 0 plus 3 is 3 over 0 squared is 0 times 2 is 0. 3 over 0 would be undefined. So it can't be 0, it can't be 5, and it can't be negative 5. Okay? And then let's look at 7. Oh, let's see. We got a cube, a difference in cubes, because you could do it as 1 cubed. So we got x plus 5 times x squared plus x plus 1 over, and we're going to break this up. Same sign, switch, always plus, x and 1, x squared, 1 times x is x, and 1 times 1 is 1. That scratches these guys. Leaves us x plus 5 over x minus 1, and x cannot equal 1. I know that because if I add 1 over and do the cube root, it's going to be a 1. So those are my answers. All right. Dividing. To divide one rational expression by another, you multiply by the reciprocal. You never divide fractions. You stay, change, flip. Stay, change, flip. Okay, stay, change, flip. If it's A divided by B divided by C divided by D, it becomes A divided by B times D divided by C. You flip it over. So they do that here. Notice the 2x minus 3 comes up, x plus 2 comes down. Then we start to do the reducing. Okay? Divide is stay, change, flip. So here we're going to stay 7x over 2 times x minus 5 times, I just flip it up. We're going to go quadratic, break it apart. Each one gets an x. Factors of 30 that add to 11, 5 and 6, and they're both negative. And then in the top, we can pull out an x, leaves us x minus 6. Scratch, 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 scratch. 7 over 2. X cannot be. We had a few things that it cannot be. So, originally, we're looking at this problem, what it cannot be. We had an x minus 5, so it can't be 5. We had an x minus 6, so it can't be 6. We had a 2x minus 10, right? This x factored out, well, they're doing it off of the times one. That's what they're doing, because they pull in a 0. They also say it can't be 0. Because when you do that flip over, it becomes a problem. So this is what we're looking at, but we're also doing it here, okay? Look at it there at the multiply space, but before you do any reducing. All right, stay, change, flip. Ooh, we got a good one. A slide and divider. So x squared plus x minus, let's see, 60 and 5 is 30 is 90. Factors of 90 that subtract to 1, that'd be 9 and 10. The 10 is positive. If we slide a 6, we got to divide a 6. And it doesn't go into there, but if we reduce it, it's x minus 3 over 2. And it doesn't go into there, but if we reduce it, it's 5 over 3. So 3x minus, 2x minus 3, and 3x plus 5. That's what's going to go up there. So 2x minus 3, 3x plus 5, and over 4x squared. Change the sign, and then we're going to flip it over. Well, this is over 1, so we're going to put the 1 on top, and we can pull an x out of this guy, and that leaves us 3x plus 5. I can scratch. Now, what would be better is if I scratched a little softer. Okay, so I can see what's going on. So I got 3x plus 5 and 3x plus 5. They go away. And that's all that happens. So 2x minus 3 over 4x to the third. And x cannot be 0 or negative 5 over 3. Okay, can't be 0 or negative 5 over 3. I mean, it could be 0. I would throw that one in there, but I guess it could, because if you put a 0 in for all of the x's, everything goes to 0, and you can do 0 divided by 0. You just can't do any other number. So, questionable. I'd put it. Okay. Word problem. The total annual amount I, in millions of dollars, of personal income earned in Alabama in its annual population P in millions can be modeled by this equation and that equation, where T represents the year with T equaling 1 corresponding to 2001. Find a model M for the annual per capita income. Per capita means per person. Estimate the per capita income in 2010. Assume T is greater than 0. So per person. So they want income per person. So they want the income times the people. So they want M to equal I times P. So M equals 6922T plus 106947 divided by 0.0063T plus 1 times 0.0343T plus 4.432 over 1. That's what they're looking for. Do we agree? Per. I'm an idiot. Look at that. Per. If you do miles per hour, you do M divided by H, right? You do miles divided by hours. That's miles per hour. So we don't need a multiply, we need a divide, which means we're going to stay, change, flip. 6922t plus 106947 divided by 0.0063t plus 1 times 1 over 0.0343t plus 4.432. And we're going to multiply them all together. All right. Or really what I would do is just continue this through here and just say, okay, this times that, all in one thing. Because it's all real life and it's all decimals and bits and bobs and boops, we're not going to find a common factor very easily to go through all of this. So this is the equation that we need. And then we need to do m of 10 because we're going to plug in 10 for 2010. If 2001 is 1, then 2002 is 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to do m of 10. So that means 6922 times 10 plus 106947 over 0.0063 times 10 plus 1 times 0.0343 times 10 plus 4.432. And that's going to be some sort of a funky decimal. 6922. Ooh, where's my 6? Times 10 plus 106947. And then what we want is that whole thing divided by 0.0063 times 10. Where's my times at? Times 10 plus 1 times 0.0343 343 times 10 plus 4.432, and hopefully we get about the right number. All right, did I get all of my decimal places and stuff in there? Close. There we go. Close. That times that. Up here. Close. Nope. Guess I don't need it. Yeah, I think I need that. There's another one over there. There we go. So, approximately, because these are per capita, means per people. So we're going to round to the nearest whole. So $34,707 ish. Man, that's a monster. Mainly just typing it in the calculator. That's the hard part. Okay? All right, find the quotient. Give these two a try. Come back, see how you did. All right, stay, change, flip. 4x. 5 comes out. X minus 4. Change. Flip it over. So we got x, factors of 8 that add to 6 is 4 and 2, and they both need to be negative. On the bottom, x comes out, and you got x minus 2 left over. 4/5. And x cannot be 4, 0, or 2. Okay, looking right here. This is the 0. Opposite to get out, that's the 2. Opposite to get out, that's the 4. All right, let's look at number 9. Ooh, okay, I'm going to have to slide and divide. So slide to the back. X squared plus 3x minus 10. Break it apart. And then we're going to slid to the back. If you slide it, you got to divide it. Factor to 10, it's subtract to 3. That'd be 5 and 2. And then you got to divide it. 2 goes into 2, makes a 1. So we got 2x plus 5 times x minus 1 over 6x. Change, and then flip it over. 1 over, we can pull an x out of there. Makes it 2x plus 5. Then scratch for those. That's all that can mix there. So we got x minus 1 over x times 6x. You could write it as x minus 1 over 6x squared. And x cannot be 0 and negative 5 over 2. Opposite to get out, but you also have to divide by the 2. Okay. Dun, 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 dun. And we're done. That's a lot.